merchant PCI DSS compliance. So today we're going to talk about the new PCI requirements related to payment iframe protection. We're going to talk about Jscrambler's solution. Excuse me. I apologize. I forgot to start my video there. There we go. Now you can see everybody. Hi. Or now you guys can all see me. Hi. And we're going to talk a little bit about our review at online of the solution and ensuring that these compliance requirements. We'll get into details on that kind of stuff in a bit. So with me today are myself. I'm Jordan Wiseman. I'm a QSA and an advisor with Online Business Systems Cybersecurity Practice. I work in various industries, but as a QSA, of course, I spend a lot of time in the payment field. With me today from Jscrambler is Pedro Fortuna. He's the co-founder and CTO of Jscrambler. He leads their security research and product innovation. He's been doing this for 15 years, researching and working in web security, primarily not just payments, but all things web security. His main interests recently are in the areas of application web security, reverse engineering, and software engineering. He's a creator of solutions that require code writing, sandboxing, or both of those things. He's the author of several patents in application security and a regular speaker at international security conferences. Also, we have Gareth Bowker, who's been involved in the payment card industry for, I don't know, about 20 years or so. It seems like we've all been doing this for forever. He's worked at an ASB, he's worked for several QSA companies, as I do now, and he's worked at the Security Standards Council itself, which is the group that puts out all the PCI standards. In fact, he was their director of training and later became responsible for their information security and the council's own PCI DSS compliance. He now works at Jscrambler and he serves as a PCI technical advisor, helping customers understand their products and address their PCI related questions. So a couple housekeeping items for the webinar before we get started. This webinar is scheduled for 45 minutes. We might take 50 or 60. We've got some specific details to go through. We're going to do a demo of the solution and talk a little bit about how it overlaps and achieves PCI compliance. And specifically, we're going to get into some of the details there on the perspective from merchants and payment service providers dealing with tools like this, as well as some information for merchants and for auditors and assessors, so QSAs, ISAs, and so on, dealing with this kind of stuff. Attendees will be able to post questions in the chat. Feel free at any time to post a question either in the Q&A list or in the chat. We've got some folks here with us that are monitoring that kind of stuff, and we can answer those questions. There will be, of course, time at the end for Q&A. We're going to have a little bit of presentation, so some more of us talking actually for a bit and talking kind of about the solution of what's going on, and then you're going to get to actually see it in action in a real demo and not just video recordings and screenshots and stuff. We'll actually watch the product work. Like I said, there'll be a Q&A section at the end. Everybody here today will receive an email after the webinar with early access to the white paper that we wrote about the solution, about our detailed testing of the solution and how it solved some of the payment page security common attacks that are used against those kind of platforms, as well as covering some of the compliance related specifics about how it helps achieve PCI compliance, how it makes things easier, and what the considerations are in managing compliance for folks out there dealing with this kind of stuff. There will be a couple of polls later on in the webinar as well, so keep an eye out for that and feel free to respond. The agenda for today, a little bit more formally, I'm going to talk about the background, sort of why these are changes, what happened in the version in the DSS that kind of got us to this point, but what happened in the payment card industry generally that led to changes in these addition of new requirements to the DSS. Pedro's going to talk about Iframe Integrity itself, the features of it, how it works, how it secures things, and then Gareth and I are going to run through an actual demo of the solution in action so you can see it. Gareth will be kind of driving the practical application of the solution itself, Iframe Integrity, and I'll be talking a little bit about the compliance aspects of it. And then we'll get to that Q&A section at. So let's get going. Let's talk about why Iframe Security Matters, why it's in the DSS, and the current version of that is 4.0.1 right now. So this is sort of like, why are we here today? What's going on? Why did Jscrambler start working on what became Iframe Integrity? I mean, you guys have been doing this for probably a year and a half, I think. And sort of why this matters. And this basic reason is that e-skimming, which is just like physical skimming, where somebody would put a device on the card reader, try to intercept credit card data. Cyber criminals out there have come up with a lot of ways of infecting websites or adding JavaScript to a website to do the same thing, to intercept the card as it's going through. These numbers are reference some research that we've done recently. I think these ones are from Recorded Future, from their research division, talking about the fact that just through their observation and monitoring and looking at stolen cards that got posted to the dark web or some of the so-called clear web sites that are listed, that kind of stuff, there were 70 million in 2023. And this problem is getting so large that by the time they did the same research at the end of 2024, there were almost 270 million stolen credit cards posted. Similarly, sites getting infected with JavaScript e-skimming attacks, so-called major card attacks or e-skimming. There's a few different terms out for there. Grew in the same period, from almost 3,500 to 4,000 in 2023 to over 11,000 active sites in 2024. And these are online actively infected sites. An example of the kind of reasons that this gets so complicated and so hard to deal with, folks. Here we have the Cosmic Sting vulnerability that was announced in 2024. So this was discovered and reported to Adobe in January. By June, Adobe had made it public and released a patch and told everybody, hey, you got to get this up to date. But patching lags behind, and it's hard for people to keep on that kind of stuff. And so by October 1st, 2024, there were still 4,300 active servers out there infected with just this one malware at taking advantage of or a couple of malware taking advantage of this one vulnerability out there. And that's just a small sample of all the kind of things that are getting out there. So in response to these issues and how bad they're getting and how pervasive this kind of a problem is, when the PCI Security Standards Council was updating the data security standard from 3.2.1 to 4.0 and now 4.0.1, they realized they needed to do something about this, to go from what's always been, frankly, a good set of specific technical security controls to protect cardholder data, but really you can use it to protect any kind of data. But they needed to address this problem a little bit more directly than just implementing good configuration standards for your web servers and that kind of stuff. So they created these two requirements specifically to address this issue. So the first one is 6.4.3, and this is a requirement. So requirement 6 itself is about vulnerability management and secure code development and so on. This requirement is really about designing, implementing, and deploying secure web applications. So specifically here, you've got to know what scripts you're including in your payment pages and the pages that contain those payment pages. And I'll talk a little about that in a second. You have to know what they are. You have to make sure that they're the ones that you expect them to be and that they haven't been tampered with or compromised or infected as they're running on, as they're deployed to and as they're running on your web servers. And just an aside real quick, and Pedro, I think we'll talk about this a bit more, but when we're talking about the payment page, so the Security Standards Council defines the payment page as the collection of fields, which are often presented via iframes or other kind of forms like that. They collect payment card data, so the card number itself, the cardholder name, billing zip code, CVV code, or card verification, values, that kind of stuff. Those together are the payment page. The page that contains all those, if they're not itself on one single page, is what we're calling the parent page. And both of those things are related for ensuring that your e-commerce pages are secure. So the second requirement, 11.6.1, this is about, so requirement 11 generally is about testing and monitoring, the security state of your systems out there. And requirement 11.6.1 related to this payment thing says, okay, so you've deployed these applications, you've made sure that they're secure and that your payment pages haven't, or that the scripts on your payment pages haven't been tampered with as they've been deployed. This one says, okay, now that they're out there, you need to monitor to make sure that the scripts are delivered to consumers in a way that hasn't been modified and haven't been tampered with and hasn't been affected anything. And you have to monitor the security impacting HTTP headers that are delivered to the consumer's browser as well. So these are things like strict transport security and secure handling of cookies maybe, and no caching for TLS sites, that kind of stuff. Basically to make sure that if you've configured the sites to be secure, to deploy or to assemble and deliver the web pages to consumers' browsers in a way that's secure. Now you have to monitor to make sure that that is not being compromised or changed or intercepted. So this stuff to protect against man-in-the-middle attacks and some client-side kind of stuff. So why are we focusing on iframes specifically when it comes to web security? And the reason that this is such an important common aspect for PCI compliant merchants and why there are so many solid payment security providers helping to help provide and deliver those forms for gathering that payment data is all about reducing the scope and complexity of a PCI compliance effort. Usually the discussions for getting there at most organizations work something like this. You've got a payment page, you need to be compliant. So you said, but how do we do this to make this easier? PCI is a good standard, but it's a prescriptive technical standard, which means there's a lot of details to go through and a lot of minor things. And if you're primarily an e-commerce merchant, or if that's a large payment channel for you, it can be a lot to have to deal with. So when they start looking at the different ways in which you can achieve PCI compliance, they often look at the council has released a series of documents called self-attestation questionnaires that are designed for merchants that have usually only one payment channel, but in certain circumstances where they've, say, outsourced the handling of payment processing to a payment service provider who's going to provide you with iframes, for an example, they have created the SAC-A as a subset of the overall PCI requirements as a guide to say, look, if you've done it this way, if you fully outsourced card data, these are all the requirements that are actually still applicable to you. So it takes the total set from like 375 down to, I think the most recent SAC-A has 30. So that's more than a 90% reduction in the level of effort or the level of controls that might apply to you, for example. So as you can imagine, it's an attractive thing for folks to go after. That said, the SAC-A only applies to merchants that fully outsource the processing of payment card data. So that could mean they've got a third party, interactive voice solution for are they taking cards over the phone, or increasingly commonly and probably the most common thing we see out there as QSAs these days is for folks to outsource processing on their website to a payment service provider who uses iframes that they provide and secure to gather that card data so that none of it ever actually touches a merchant system. That's ideal from a scoping perspective. That's pretty great from a security perspective. And that's exactly the kind of situation that we're looking at here, because those iframes, as they've been becoming the most common or the more common way of gathering that card data from websites, the bad guys, of course, are targeting them much more frequently, which has led to those numbers of compromise that we were talking about before. And part of the process here when you're doing SAC-A is that merchants have to get confirmation from the payment service providers that their site is not susceptible to those attacks anymore. In other words, that the payment service provider has delivered them and secured them in a way that prevents those e-commerce web skimming attacks, like I mentioned before, or implemented or possibly by implementing a tool like Iframe Integrity. We're going to talk about that. So in fact, I think now's the time. Pedro.
Thank you, Jordan. I'm going to pick up where you left. The SAQA new eligibility and the FAQ 1588, they clarify that merchants need to confirm that their web pages are not susceptible to script attacks. That confirmation could be obtained by implementing 643.11.6.1 or something equivalent. And it could be delivered by the merchant or by a third party, including their TPSP or payment processor solution. Luckily, we had such a solution. I think this was in last February. And we had then the solution for a year, roughly, that we rebaptized as Iframe Integrity. And this solution can be leveraged by TPSPs and payment service processors to make their merchants SAQA eligible. I'll tell you why and how later, but let's park this for a second and let's start at the beginning. So if merchants have iframed their payment pages, why isn't that enough? Well, because a number of attacks, such as iframe overlay or iframe hijacking, are still possible, both silent or double entry skimming attacks, and all of these from arbitrary scripts running on the parent page. So next, I will go through a couple of these attacks to give you a sense of how they work, what's their mechanics. Starting with the iframe overlay. So in an iframe overlay attack, a compromised script creates a new iframe and overlays it on top of the legitimate payment iframe. So this iframe is fully controlled by the attacker. So in some cases, it simply captures the data and sends it to an attacker-controlled server, while in other cases, it's made same origin. So the compromised script can access it from the parent page. Either way, the result is the same. So the cardholder data is schemed, and all of it happens without the user noticing anything. In an iframe hijacking attack, this attack is a bit different. So here, the attacker interferes with the payment iframe creation process, which means that he needs to run first the compromised script. So in this example, the compromised script is monkey patching the set attribute DOM method in a way that when this method is called with the attribute source of an iframe element, it will actually replace the destination address with one indicated by the attacker. So later, when the PSP script runs, eventually it will call this DOM method, which will result in the monkey patch method being called instead.
Hey Pedro, you talked about monkey patching a couple times. Can you define what that is real quick for some of the folks on the line?
Right. That's a good point. So monkey patching in JavaScript means replacing the implementation of a method by another one. And essentially, it works like a man in the middle. So anyone after the monkey patching, if they call that method, the monkey patch version will be called instead of the original one. So it's like a proxy in front of the original implementation, but it's fully transparent. So when any code calls that method, it doesn't that code is not aware that it's calling a monkey patched version of that method. Um, so it doesn't so it's used for other purposes. It's not used primarily for attacking code. It's used for extensibility, composability of software. So it's a feature of the language. But unfortunately, it's also extremely useful for attacking code to be, replacing functionality with their own with minimal hassle from the attacking side. So next, fake iframe. This is a very simple attack, and basically it is what it says it is. It's a fake iframe. So any scripts at any given point can decide to create a new iframe and add it to the current DOM. So usually we see this kind of thing happening earlier in the payment flow compared with what would be expected with the legitimate payment form, with the goal of tricking users. So the users see a form, they realize it's time to enter the payment details, and when in fact this is a fraudulent, a fake iframe that is only meant to collect this data and exfiltrate this data. This often results in a double entry skimming attack. So later in the process, the user will be shown like an error, like, okay, please insert your data again. But the second time around, it will be doing it over the legitimate iframe and forms. So initially, when we were thinking not of the Iframe integrity, because as I mentioned, we had this for a year before the rebaptizing it as the Iframe integrity and positioning as a solution for SAQA and FAQ 1588 eligibility. At the very beginning, we thought of leveraging TPSPs and payment processors for delivering 643 and 1161. But we immediately realized that maintaining script inventories and responding to alerts across thousands of merchants would be unmanageable for these service providers. So we needed to find a different approach. And this challenge essentially became the seed for what would grow into Iframe Integrity. So at the very beginning of designing this product, we had a pretty good intuition on the restrictions that the solution had to work with, and those became the design goals. So the number one being not requiring the cooperation from merchants. So obviously this was the main problem that we were trying to solve. So that meant no authorizations or justifications needed from merchants. Even asking merchants to add a script to their parent page would be problematic, given the potentially large number of these small merchants that would be covered by the solution. And another design goal is that ideally, PSPs should not need to do anything on a day-to-day basis unless something really problematic happens, like a security incident, which we assume that wouldn't be an everyday event. So no manual validations, no responding to mundane alerts, and everything that needs to be blocked is already blocked by default without the PSP's intervention. And last, but certainly not least, the solution must be able to scale to hundreds of thousands of smaller merchants. So we knew right away what that meant, that we would have to avoid merchant-specific configurations. So overall, the solution needed to be both performant, efficient, and low maintenance. So since we couldn't expect merchants or PSPs to maintain script inventories or to authorize scripts and justify their inclusion in pages, the solution needed to follow a customized approach, or in our case, we decided to use the compensating control because not every merchant is assessed, or they cannot use the customized approach. So using a compensating control seemed to be the best approach. So we didn't know at that moment that later on with the FAQ 1588, it's not even the compensating control, because you're not actually meeting the two requirements. You're just becoming eligible for SAQA. So technically, and maybe Gareth or Jordan can clarify later, I don't think it's even called using a compensating control in this context. So instead, what we needed to do in order to, back then, use it as a compensating control, we had to address all the risks posed by scripts running on the parent page that could potentially lead to the skimming of cardholder data, because, following the 643.1161 to the letter was not an option because it wouldn't scale. So any solution that we'd come up with would have to mitigate all of these threats. So at this stage, that meant, we had a list of these attacks, and we had to come up with mitigations for all of these using the solution. So at this stage, it also became clear that we had to use behavior-based monitoring via an agent, one that would effectively prevent misbehaving or malicious scripts running on the parent page from interfering with the payment iframe, or from creating new iframes or forms that could be overlaying the legitimate form and iframe. So in order to prevent monkey patching, in order to prevent some of the attack methods, we needed a script running on the parent page. And to ensure scalability, the agent would not be able to rely on sandboxing rules that would be merchant specific, because that would very quickly compromise our ability to scale and to manage the configuration, given the sheer number of rules that would require from us to maintain. As for deploying the agent, rather than asking each merchant to add it to their parent page, which again would be a non-starter, we would partner with PSPs to piggyback on their existing scripts, which is already running on the parent pages of all of these merchants. So that way, it all comes full circle. We integrate once with the PSP, and every merchant out of the box benefits automatically. So essentially, it starts running this agent that will mitigate all of these attack.
Pedro,
So
we got a question real quick about from Eduardo, who asks about explaining how code obfuscation for React might work. Can you talk a little bit? And I know you're about to talk about how the scripts are, but can you talk a little bit about how iframe integrity, works with, but is a little bit separate from web integrity, and maybe how the more traditional web security solutions are broader than what we're talking about today.
So what is the question again? The original question, the one from
Yeah,
the
he
attendee?
says, can you explain how code obfuscation for React would work? That was his original question.
For React. Okay. Yeah, like you say, it's a separate process. You don't really need to obfuscate any scripts as a merchant, as a PSP. Um, if you use something like Iframe Integrity out of the box, your PSP script will be obfuscated. If it has Reacts, it doesn't matter, because as long as the it's like standard JavaScript, it will be supported by the transformation process that is built into the CI/CD. So no particular problems would result from having or using React in JavaScript that needs to be protected. Hopefully that answers the question. For some reason, I cannot see the questions myself. So thank you for pointing out that I had that question in. So let me explain how the solution works. And I was already, I guess, like explaining a little bit of it. So initially, it just requires a simple integration into the PSP's CI/CD process. So we presume that the PSP has a script that is now injected into the merchant's web page, parent pages. And this script is, it results from a CI/CD process. And the only requirement is to add an additional step in there where that script will get protected, with runtime defenses like anti-tampering and anti-monkey patching. And we will add additional logic that will be responsible for loading the Iframe Integrity agents once the PSP script loads. So when the user eventually gets to the checkout page, this script is loaded. It then secures the whole environment. So basically sets all the runtime defenses that are needed to make sure that there's no interference, and only then creates the payment iframe. So when the payment iframe comes, it's already like loading in a much more tighter and hardened environment for loading and preventing interference from any other script executing at the same time. And that's it. So this is the gist of it. And the agent, after it loads, as I said, starts monitoring every action from every script out there, it will restrict certain actions from scripts, like their ability to create iframes and forms, especially being able to create those iframes and forms and overlaying the legitimate payment iframe. It will prevent tampering to the iframe. So for instance, if a script tries to modify the source attributes or tries to change how it's working in any way, it will be prevented, restricted and blocked from doing that. And we are also shielding a bunch of DOM methods that are risky in the sense like they can be used for creating iframes, creating forms, and things like that. And the ultimate goal is to prevent all of the attacks that were mentioned. At which point we can claim that we no longer need to be, maintaining an inventory of scripts and authorizing scripts, because whatever, it doesn't matter how malicious they are, whatever they can do, they cannot interfere with the normal flow of the payment iframe. Every blocking that is necessary is configured by default so that the PSPs and payment processors don't need to, respond to alerts and all of that. That would compromise the scalability, operationally speaking, of the solution.
So Pedro, I think that's an important point. So this script, while it's designed to protect the iframes against compromise, this will also prevent other page breaking, scripts from potentially getting in the way of your customer.
Exactly. So it does reduce overall risks on that parent page, not just for the iframe. So essentially, what you can think of it as something that it is in place to attenuate behaviors that could, be risky for your checkout page. Not only for, making sure that the iframe, the payment iframe is running smoothly, but also from other types of interferences, such as, something like just adding stuff to your page and interfering with the checkout process. So just summarizing here, the key benefits. So first of all, it's easy PCI DSS v4 compliance, because you can make sure that your merchants are SAQA eligible, because you're basically making sure that their parent pages are not susceptible from attacks from scripts. You are rolling out it offers enhanced protection against payment card data skimming, and helps preventing data leakage in general. And it's plug and play. So integration is simple, is non-disruptive. You don't need to ask anything from merchants. It's hugely simplifies daily operations, so you don't need to every day don't need to respond to requests to authorize scripts and to maintain inventories. And essentially it makes everything easier, and reduces the risk of non-compliance for everybody. As a bonus, Iframe Integrity doesn't just strengthen security, it may unlock new business potentially as well. So PSPs can think of it as a way to, stand out from the competition, because they're offering these conveniences and benefits to their merchants, especially for larger players, because they're able to offer like a truly differentiated and valuable service. And that could mean, stronger merchant retention. And on top of that, it creates opportunities for new revenue streams, whether through, I don't know, like premium pricing, upselling, or just offering a hassle-free PCI compliance add-on for merchants who just want for that problem to go away, essentially. And that's all I had. I'm giving the floor back to you, Jordan. Thanks.
Thanks, Roger, very much for the detailed walkthrough of Iframe Integrity, kind of how it works in there. Now we're getting to the exciting part. Gareth is going to demonstrate how the product works, and I want to talk a little bit about sort of what we've done for testing. So what you're about to see is a live demo with a demonstration, but technically complete e-commerce site and solution. This is the exact same code and solution, although not the site that my team and I here at OBS Cyber tested when we were creating the white paper to go through to see, okay, one, does this really protect, the e-commerce pages or the iframes in the payment pages themselves, and can this meet the requirements of the new PCI requirements 643 and 1161. I think the only real difference you're going to see today is that in Gareth's website, because he's going to be showing you their quick managed demo system, he's got a couple of quick push buttons right there on the site to actually go through that integration process, which honestly is kind of neat to see, because you can see how quick it actually is to integrate the script in there. I didn't have the benefit of that when I was doing the testing, so I had to do it the old-fashioned way with an actual, e-commerce site and interacting with the browser a little bit more directly. But and the other thing that we saw is the version that I tested with, we left enabled some messages that would show up in the browser console. One, so I could get screenshots for the white paper for you folks to see that, but two, because that helped us kind of recognize in real time that things were happening. Gareth said he's going to actually show you guys what it looks like on the back end when the script actually takes an action to protect the site against that attack. All right, Gareth, I think we're ready to play.
Okay, let me just bring up our little demo sites. Here we go. So I hope you can all see the Jscrambler shoes website here in front of you.
And when are the shoes going to hit the market, Gareth? Is that?
Oh, very much pre-production at the moment, I think. Yeah, so what I'll be doing today is showing a couple of different types of attack. We've got this Jscrambler shoes demo website. It's an e-commerce site selling rather overpriced sneakers or trainers. And we'll show a couple of attacks, and we'll then show Iframe Integrity protecting it. So as I mentioned, it's a very simple, straightforward e-commerce site selling trainers, sneakers. I've already picked some out. And when we go through here, with it being a demo, I don't need to fill in any of these details, but we can go straight to the payment page. Now here, we've actually got three different types of payment. It's these last two here that we're going to be focusing on today, because both of these are provided through an iframe that is coming from our demo PSP. So this is an iframe here that's loaded in. We have another one over here. They look identical because it's the same PSP code, but we've got them separated out so that we can see the two different types of attacks being injected.
And for reference, real quick, when we talked before about payment page versus parent page, so on these two, the iframe that's included, that it's actually gathering the credit card number, the cardholder name stuff, that's the payment page. This web page that contains those iframes, you saw the Jscrambler shoe page, the check, all that kind of stuff, that's the parent page.
Yeah, thank you. Right, so what I'll do, I'll just put a simple transaction through so you can see the usual flow of this. There we go, we've made a payment. So I, as a customer, I'm happy, I've got my confirmation here. Jscrambler Shoes has received the order. Everything is working just fine. However, this site...
Oh, hold on just a sec. One of the attendees mentioned that you're not actually sharing, that their screen's not showing up. Can somebody else confirm in the chat, is that everybody that's only seeing the title screen and not the demo?
It is telling me that I'm sharing screen, so it's possible. It's the other.
Okay, they say they got it now, so I think it might have just been a tech thing. But thank you very much for letting us know. That would have been not much of a demo if you couldn't see it.
It would not, thank you. Right, so just to let you all know as well, there's a whole load of JavaScript that's running on that payment page. Just like many e-commerce sites out there, the Jscrambler Shoes website has tag managers, it has analytics software that's running on there, and so on and so forth. And unfortunately, one of those third-party sites has been breached by an attacker. So what we can do is we can simulate one of those attacks being added in now. And so this is the little cheat bar that Jordan was referencing a minute ago. This is going to allow us to inject one of those attacks into the payment page. So I think I'll start with the iframe hijacking here. So we'll enable that, and that now has changed that third-party JavaScript site to include that attack. What that means now is when we come through this process again, and we go to the payment page, so this was the iframe hijacking one. When we go to here, we'll see, there we go, the original iframe that was there has now actually been monkey patched, just as Pedro was talking about earlier on. What we've done here, to make it really, really obvious that this is a monkey patched, very different iframe, we've actually put this big red border around it. This is to give everybody here a visual indication that this iframe has been tampered with. Obviously, in a real-world attack, the attacker would simply be modifying those kind of hidden attributes, those hidden methods within the JavaScript to modify the behavior of the iframe. But for the demo here, we've made it a bit bigger and we've made it bright red as well, so it's nice and obvious for you. So if we were to go through and make a payment here, this one is actually going to show what's called a silent skimming attack. So because of the way that that iframe has been hijacked, when we click on confirm, that transaction has gone through again. However, as a customer, I've seen nothing different there, ignoring that big red box. Jscrambler Shoes has received the order, but the attacker, through that monkey patching, has also been able to capture that data and send it elsewhere. So this is quite a nasty type of attack, and it's one of the ones that Iframe Integrity will protect against. So let's go ahead now and inject the other type of attack, so the fake iframe, and we'll go through that process once more. Just to show it's there, I won't bother doing a transaction in the interests of everybody's time, but you can see now here, when you give it a second, there we go, that fake iframe now has been loaded here, slap bang on top of the original iframe. So any customer now would click in here, they type in their details, and as Pedro was talking about, this would be what would be called a double entry attack now. You'd enter them in here into this fake iframe. The attacker would send it off to their server and probably put up an error message saying the transaction failed, please try again. And then the second time, it wouldn't load this fake iframe. You'd put the transaction into the original iframe and it would go ahead. So we've now got these two iframes here. Both of them have been attacked, one being hijacked, one being a fake iframe.
One thing, Gareth, that I think is worth pointing out here real quick. Can you click on the payment form tab so they can see what the original one looked like?
Oh no, so this is actually this is a different one yet again. This is for a different demo, so we're not looking at this one today. That's but right. You will see the original one in just a minute.
Well, what I want to point out really was one of the reasons that these attacks are so insidious and have been so successful, and the reason that the council created the new requirements and that we are testing solutions like Iframe Integrity here is because, as you'll notice, when that payment form was replaced, it looks very different. But the attacker often designs their forms to look like common e-commerce platforms because they understand customer experience almost as much as the merchants do. They understand that it's got to look legitimate, it's got to look good, it's got to look like what the consumer expects to see, so that they're more likely to just input their credit card data in there.
Yeah, there we go. There's the original form there again, just to show the difference between them. There we go. And what I'll do is I'll just re-inject that attack, and then we'll be able to just move on with adding in Iframe Integrity. So I appreciate Eduardo has a hand raised there. Is there a question or a comment?
Yeah, he was asking about price. He asked before if the solution is free. He wants to know if this is included with the product or if this is a free offer.
So everything that you're seeing here is part of Iframe Integrity. In terms of pricing, if you want to contact us, it is dependent on the size of the company and the amount of effort and so on, but we can talk about pricing separately around this. But yeah, everything that you're seeing here is all included, and everything that I'm describing here is as you would get within the product. So at this point now, we can see Jscrambler Shoes has a problem. They've had their JavaScript attacked. There's two different types of attack that are running here. So what we're going to do now is we're going to enable Iframe Integrity. So this little button up here, when I click on this, what it's going to do is it's going to kick off a process within our test PSP. And what it's going to do is it's going to kick off the usual CI/CD pipeline to deploy a new version of the payment service provider's payment script. It's exactly the same script as we've seen a minute ago, with one difference. At the end of the process, before it gets deployed, it's going to send it to Jscrambler servers. It's going to add in Iframe Integrity. It's going to add the code integrity, JavaScript, polymorphic obfuscation, package everything up into one, and then it's going to deploy that back to the PSP. The final step then for the PSP is to deploy that themselves to their customers. And the idea here is that it's deployed instead of the existing script. So it's not a new script, doesn't require any changes by the merchant in this case. It simply replaces that original PSP script. So if we do this now, there we are, we've kicked that off. This is a real-time demo, so it is actually sending it off to our servers, and it's adding in the Iframe Integrity. It's adding in all of the additional protection that we have, passing it through code integrity, going back to the PSP, and there we are. Within what, 7-8 seconds, something like that, that process is completed. So that now is Iframe Integrity added into the payment script and now deployed. So one final thing, what we're going to do again is go through the payment process here, go to the payment page. Remember here again, it's these two here that we're looking at. So for Iframe hijacking, you'll see here the hijacking hasn't happened. We've now got the original iframe visible here. For the fake iframe as well, that has been prevented from being able to overlay that fake iframe. Just to show as well, those two attacks, they are still there. So what this means is that that third-party website is still attacked. It's still been breached. It is still trying to inject this malicious code into the payment page. So what's happening here, the PSP's payment page here is loading in Iframe Integrity, which is running within the Jscrambler shoes page. So this is now in the parent page to Jordan's description a minute ago. And that now is preventing that third-party JavaScript from being able to do any tampering.
Yeah, and it's worth noting that the web server itself hasn't been changed. So even though it hasn't been, updated, if there was the vulnerability that the attackers were using in order to inject their malicious JavaScript, that hasn't necessarily been fixed. PCI does require that you patch your systems to keep up on that kind of stuff, but it's just worth noting that nothing on the web server itself changed, except that Iframe Integrity is now running, preventing those injections. And I think, Gareth, now we're going to look at the sort of proof in the pudding, right? The console.
Yeah, that's right. So what we'll do now is we'll just jump back here. So we've got a live feed of data. Let me just refresh that. So we've got the live feed here. And you can see on these two lines here, these are the two types of attacks that we saw. So this was editing of an existing iframe. This was the hijack attack. And you can see here that that was blocked. And additionally here, the addition of a new iframe. This was the fake iframe that was being added. And again, this has been blocked here. So this is all of the monitoring and the logging that's going on within Iframe Integrity, sending telemetry back to us, or sending it back to the payment service provider for them to be aware of the fact that that merchant has a problem. And then obviously they can reach out or do whatever they need to do. But bear in mind here, Iframe Integrity is running, Iframe Integrity is blocking these attacks, which means that the consumers here, as well as the PSP, are all being protected here. The malicious code, the mage cart, or the attacks here are being thwarted from taking place. So that, in a nutshell, is Iframe Integrity. And I hope you can see here as well how that all ties into what Jordan was talking about with SAQA and what Pedro was talking about as well. So
yeah, exactly. So, as we said before, 643 is about ensuring that you can assemble and build a page in a secure way. We do this kind of stuff. So practically speaking, that means demonstrating that you're using Iframe Integrity or showing that that's part of the script, right? 11.6.1 is what requires you to be monitoring the sites to make sure that they're not tampered with. And what Gareth just showed in the console there is that proof that, like, here's the events, you can see what's being happening. And not only is the event there, but it's being handled in real time. So it doesn't require somebody to respond to the event, and there's not going to be a 3 a.m. Pager going off for somebody to go out and fix the website because you're being compromised. Iframe Integrity has stopped it from happening in the first place, which is really, I mean, that zero maintenance idea behind this is kind of fantastic. Eduardo asked as a Q&A too, if this is only for sites that accept payments. Of course, Iframe Integrity can be used with any site that uses iframes, especially third-party iframes, to gather sensitive data. So, for example, you might see this on sites where you're using, say, tokenization platform for protecting, insurance IDs or government IDs or other kind of sensitive data. Today, specifically, we're talking about this and kind of part of the interesting, what started, Pedro and the folks at Jscrambler down the path of dealing with this was the upcoming PCI requirements. But yeah, it can be used for any kind of information being collected by iframes, or frankly, any iframe you want to prevent tampering with.
That's right. Okay.
Is it safe to insert scripts into the console? So are you talking about, with Iframe Integrity in place, inserting or doing live scripting in the JavaScript console? Does Iframe Integrity block that? The short answer to that question is absolutely it will. The way that it's loaded high enough up in the JavaScript stack to prevent modification, that kind of stuff, is it would also interfere with manual scripting in the JavaScript console. That also means that it would interfere with, if somebody has client-side scripting for customization purposes to do their own, monkey patching for maybe useful purposes or decorative purposes, like people use the Grease Monkey for and that kind of stuff. Iframe Integrity also prevents those from manipulating the iframe, which means it could protect against another class of attacks there from other kind of client-side stuff. It gets a little iffy when we start talking about extensions and trying to save websites from themselves, but yeah, it will prevent direct introduction to the console as well. Eduardo, you've got your hand up. I'm not sure we can hear you, but maybe if you can type your question in the chat, or as we said before, feel free to reach out. We'll send an email after the call and we can have a more detailed or deeper discussion of things if we want to as well. So we've had a couple of good questions as we went along during the presentation. I appreciate everybody, answering those and kind of being engaged as we went. There's a poll up right now talking about what would this be valuable for. PCI DSS compliance, anti-skimming, or data privacy. Most folks seem to think that it'd be responsible for everything so far. We'll see the results in a few minutes. So we have one more question. Somebody asked, if the merchant's web page is a single page app, does the product inventory all the JavaScripts? Can we see what the inventory page on the product looks like? So this is a question about Iframe Integrity's kind of overlapping functionality with web integrity. And I think, that might be a larger discussion. So most folks are familiar with Jscrambler's existing security tools. And in terms of the page, the script inventory and that kind of stuff. So I think how that integrates to the single page app may be a bit more of a detailed conversation. But it is worth noting that those are they're separate but overlapping products, and so Iframe Integrity itself doesn't provide some of the script inventory. However, it's a really good question in that one of the requirements or one of the elements of requirement 643 is to inventory all those scripts. So for a merchant whose payment service provider is using Iframe Integrity, that merchant may only have to rely on or even know about that one script on the payment page. For the payment service providers, they're still going to need to know about other scripts that they inject or that they use in order to assemble their solution. And merchants may too if they have other things than that payment service provider on their parent pages. Those inventories still have to be maintained. So that might mean pairing Iframe Integrity with Jscrambler's other more traditional tools or other mechanisms there in order to make sure that that script inventory is complete.
I would just add there as well, it depends on which kind of route they're taking to compliance. So if they're doing a full on-site assessment, then requirement 643 and 1161 would apply as they're written. If
Right.
a merchant is simply using, a third-party service provider, payment service provider here, and they're eligible for SAQA, then the way that Iframe Integrity is working here, as you just saw, it's protecting the payment page there from any script attacks from the parent page. And so you'd meet the eligibility criteria of SAQA there for that PSP.
Yeah, it's a really good point. Steve Martinson made a comment in the Q&A about, as a QSA, we remain independent with regard to solutions recommended, and that's absolutely true. So one of the reasons, as I mentioned before, that we were working with Jscramble, and we OBS Cyber, part of OBS Global, we've been a QSAC for a long time, and we partner with a lot of solution providers in this space. And we were excited to look at Jscramble's solution at first, mostly because as a QSA and as a former engineer and developer myself, what I really wanted to do was poke at it because I was like, it can't be that simple. Let's see if this really works, right? I wanted to be able to go out there and be product agnostic. And that led to creating the white paper and talking about all this kind of stuff, and even some of the additional recommendations in there that are, it's comments on, for assessors, ISAs, QSAs, and so on when they're looking at these kinds of solutions. But you're exactly right, Steve. We're agnostic when it comes to or independent, and I don't necessarily as a QSA care what solution a merchant or merchant service provider is using and providing these features. And they just need to do something, and this is a way of addressing it, potentially simply. So we've got a second question out there, which is, would this particular product be of value to you? To Steve's point, as a QSA, not necessarily. It doesn't make my life any easier in assessing a merchant, but it might make a merchant payment service provider's lives easier. And there are a few other products on the market out there that are addressing this. I don't think in a similar way from what I've seen, but they're attempting to do that. There's only really two that I know of that are quite complete like this. And I'm assuming that may change in a while. It'll be kind of interesting to see how that evolves in this space. Yeah, Steve, I think we're probably thinking of the same two. One of them for attached to a content. The thing's escaping right now. It's attached to one of the big CDN vendors out there, at least the one that I'm thinking. So Eduardo asks, he wants to reiterate his question from before about, does the iframe bring advanced security to the front end? I think that's an interesting question, and I think it kind of depends on that broader context about maybe what you mean by advanced security. So iframes have been used for, more broadly speaking, iframes have been used for these embedded payment pages because the sandboxing that is in place when an iframe is properly implemented, the controls that have been baked into the browser through the adoption of web standards going back a long ways, ensure that there is protection against which other elements on the page and which other elements in the browser and specifically scripts can interact with the objects that are inside an iframe. So it's a way of kind of building those virtual fences within the web apps that are deployed. They can be circumvented, of course, and there are things related to poor configurations and vulnerabilities in the stack, as well as in the scripts themselves or the implementation of the iframes that lead to their being able to be compromised. And so this is a way of preventing that. But yeah, at a basic level, that's one of the reasons iframes are what's been used for this kind of stuff, is there is quite a bit of built-in security, mostly centered around what's called the same origin policy, which means that an iframe delivered from one site shouldn't be able to interact with content that was delivered from other sites or other domains really within the page. A broader technical discussion of how that works and what that means and how to deal with that from a secure perspective would itself take, we could spend a whole hour on just that. We can spend entire weeks training people on how to do that correctly. And frankly, I think that's needed sometimes, but yeah, great question.
I will add one quick thing as well to that. So from a React perspective, given that that's a single page application, generally you wouldn't get to the payment page until later on in the process. So you wouldn't get the obfuscation, you wouldn't get the kind of protection that we're talking about here until that payment page was loaded. If you're interested in that, then Jscrambler's web page integrity is a product that would give you that much broader coverage for the front end application here. This is more focused just on the payment aspect of it, but more than happy to talk to you offline about that, Eduardo, if you're interested.
Great point. And with that, I think we're at time, everybody. We made it to a whole hour. Yeah.
Sure. Just to add on that, the web page integrity is essentially a technology that provides isolation for the browser. So it's not meant to solve every front-end web security problems out there. It's meant to provide visibility on what scripts are doing and to blocking some of those actions that might be dangerous in regards to the way they're potentially touching data and collecting data. That's what it's meant for. So yes, Iframe Integrity is a little bit more specialized than that. It will focus on hardening of iframes and the parent page specifically. So it's not meant to tune or customize and protect individual merchants being covered by that solution. So if you're looking for a broader isolation and control of behaviors across your website, then your best bet would be web page integrity, which is the broader and it has the regular 643 and 1161 module that folks can make an inventory, authorize scripts, and all of that. We also have code integrity, which is meant to obfuscate code and make it tamper resistant and prevent monkey patching. So that's the final piece of the puzzle that we bring to the table. With our products, you cannot address every web security need out there. We're kind of focused on isolation and integrity preserving aspects of the front end. If that's what you need, then yes, you can get everything from us if you want.
And for what it's worth, the question about single page applications, as they've become so much more common, and a lot of sites have developed around that, there are a suite of other compliance and security considerations of building those kind of applications. So our contact information, both Jscramblers and then online's from a cybersecurity and a compliance point of view, are in the white paper. Feel free to reach out. I mean, we would love to have a longer conversation about those elements, because it's just enough different from traditional web security that it's worth spending some extra time on to make sure that all of the right T's get crossed and all of the right I's get dotted, so to speak, in ensuring that those are built well. And with that, we're a little over time, everybody. So thank you very much for coming today and all of your really fantastic questions. Feel free to reach out so we can continue these conversations. I see there's still a few questions coming in, and unfortunately, we don't have time to get to them. But definitely, we're interested to speak with you more and kind of dive into some of the details about what is you specifically need. Again, my name is Jordan Wiseman. I'm a QSA, among other things, with OBS Global Cybersecurity Practice. And I've been joined today by Gareth Bowker and Peter Fortuna from Jscrambler, talking about the Jscrambler Iframe Integrity solution. Thanks, everybody.
Thanks very much.